Do you hear me? Or?
Yes.
Okay, yes. So, I was going to tell you about some experiences on automation from the contractor's point of view. And Pekka Kilpeläinen, in his previous presentation, told you a few things about the machine that we have invented, and VTT has developed the automation system for the machine. So I thought that I give you some experiences from real life action and automation. And I think I must represent myself again, because there are some people that came in the morning after I have presented myself. So my name is Kaisa. I present a technology and infrastructure company from Finland called Fundament. At Fundament, I work as a quality manager and also a work leader during the summers when we are working. And to tell you, I'm really pleased to have a chance to come here and tell you about our company. So what I was going to tell you, first, I think I must present and tell you a little bit of what is Fundament and what it does, because I know that most of you, it is not a familiar name, what we do. Then I'm going to tell you on the benefits that we have found using automation and the techniques we have been developing. And the case is the multipurpose rotary mixer or stabilizing scarifier. So first I'm going to tell you a little bit of what is Fundament. So we are a Finnish infrastructure company. We are established in 1994, so we are not quite old yet. Our head office is situated in Kalajoki, Finland. Kalajoki is about a little less than 100 miles from Oulu to south. It's a little place. We operate mainly in Finland and other Nordic countries, and also some operations we have in the Baltic countries, such as Estonia. Our main services are structural improvement of road construction. We do environmental services, traditional earth construction work, and also we develop different kind of methods and machines for our service fields. So mainly we have developed and constructed our special equipment that we use in our work. So we are not quite big company compared to all the others that have presented here today. We have about 20 to 30 technical officials, and in addition to that, 20 to 40 workmen. So we do this traditional earth construction, but because we want to develop all the time, so we have been focusing also on electricity kind of things, automation, ITC, bridge, road maintenance, etc. We don't try to do everything ourselves, but we have a strong network of partners, companies from whom we get acknowledgement also. So, as I mentioned before, we have special equipment in road construction field, and I'm going to tell you in this presentation about the stabilization scarifier. And we also develop and construct the special equipment with our partners and to our partners, but mainly the equipment we do is not so much commercial equipment compared to, for example, Caterpillar or something. And I think what makes us a successful company is our product development resources, and one thing is that we have really innovative and professional staff. So before I get to the case of stabilization scarifier, I'm going to tell you some benefits that we have discovered using automation with this machine. So first, it makes possible to carry out precise rehabilitation based on the precise planning. The scarifying parameters can be changed automatically, like scarifying depth, thickness. We can also change parameters like width, and the machine has automatic dosing of binder. We have discovered through using automation increasement in working capacity, as well as through that financial savings. The increasement in working capacity is up to 20% compared to traditional methods, which we have discovered. And the financial savings are up to 20 to 30%. The financial savings, which comes from the binder use. We can use the binder more efficiently because of the automation that doses the binder much more accurately. So the financial savings relate to savings in material use, which is up to 10 to 30%. The binder material can be, for example, bitumen in stabilization. And also quality control facilitates. Okay, so we go next to the case. The product name is cutter modulator, and it is stabilizing scarifier. First, some background about what was the idea of inventing this machine. So the idea for developing the scarifier is actually coming from a machine workshops. We found similarities in the working phases of engineering industry and road construction. Similarities, what we found, occur when we look at working phases, which are often repetitive. For example, in road construction, we can find repetitiveness in shaping the road by blade grader, compaction, paving, and methods used in reinforcing, such as stabilizing, which we do in this machine. So basically, based on those ideas, the scarifier was invented, and the product name, as I mentioned, is cutter modulator. And the modulator word comes from the idea that we can, this scarifying cutter is like a module that we can change different kind of tools for here. So Pekka told you about some technical facts, and I don't get into that anymore, so I'm going to tell you something anyway. So the cutter is equipped with binder feeding equipment and water spraying unit. The automation observes, for example, the control of engine body movements and binder feeding. And we have discovered that, or the idea of this machine and driving it was that using the machine is made as easy as possible for the driver. So we thought that maybe we do that driving is kind of a process that the driver works as a supervisor of the process and the automation does the rest. And I thought I'd show you a short video on the machine in action if you want to see. So I'm not sure if it cannot open. Maybe I open it from here. It's here.
It's a bug with the API drivers, so we can
Okay.
fix it like this. So what kind of means we make that as a second API. So you won't see it here, you won't see it there.
Okay. I think settings.
So
Yes, and extend. Okay.
there will be a presentation there as well.
No, it's nothing.
We'll fix it. Oh.
Definite improvement.
Okay.
That's what we do. Yeah. Okay. I'm not sure. Can you see properly if it's good? So you can see that the machine comes pretty fast, and in this process we are not stabilizing, but we are doing mixing, scarifying, where we break the old pavement and mix it with the layer that's the top layer down the pavement. So basically this is the cutter that breaks the pavement, and after that comes the compactors, and they compact the layer. I'm not sure if Pekka mentioned the scarifying depth, but it's usually about 100 to 150 millimeters. In this case, it's about 100 millimeters. So that's basically what we do with that machine now. So it's I think it's quite easy way of reinforcing the road construction. It's really rapid thing to do. Depending on the old pavement, we can do up to 5 kilometers per day. So, but it depends on the old pavement type. So the softer the old pavement is, the faster we can go. But That's basically the idea how it works. I'm not sure how is it in use here in USA, but we do that a lot.
Okay. Is there any more?
Yes, no.
So is your machine being used here? Or
In the USA or
yeah.
no, it's in Finland. It's quite big, so I think it would it would be much of a cost if we ship it here. So, but maybe we can do one for you.
Good answer.
Yes. No, under.
This one?
Under. Yes. Yes. Okay. Yes.
4 inches.
No? So as I earlier mentioned, the machine is constructed in a way that it is quite versatile. There are interfaces for optional equipment and software system, and following equipment can, for example, be added, and the idea of a module is that the equipment is added right here. So we can add, for example, a crusher, measuring equipment and sensors. They don't go there, but otherwise. Also dispensing equipment, asphalt milling unit, different optional equipment. For example, powder spreading unit if we do cement stabilization. So we can put powder spreading unit into the machine. Also, the tires can be replaced by tracks because when we cut some very thick layers and hard layers of asphalt, those tires, I'm not sure if I get this right in English, but they give up and the machine starts to pump. So that's why the tracks can be put in. Also remix stabilization equipment, including gravel hopper, continuous mixer, and screed. So what we have found and our experiences is that the driver's work gets easier when the automation handles almost everything and the driver just observes the situation. Also, the automation improves the quality of the work, and again, the driver's work is easier when we do stabilizing. The binder feeding can be controlled accurately, and utilization of old road structure can be maximized. Also, material loss decreases. Maybe I should describe, because I don't have a picture of a stabilization going on. So if we do bitumen stabilization, we have a truck with a bitumen container in front of the machine. It is attached to the machine through a hose, and there comes a metal, I don't know what's the word in English, but it is attached to the machine. And so the machine pumps the bitumen from the truck and spreads it into this unit, and that way we do the stabilization dosing.
does the machine know if something goes wrong?
Yes, apparently it can say if something's wrong, and I think Pekka is the best person to describe that, because he has been inventing the automation system.
Well, can it detect,
observe.
Also
Yeah.
how the process head goes. So it's really hard to make a machine that there is no user.
Yeah,
And I think that is not very
maybe that's the next step for you.
There's a story from Toyota that, just a quick story.
Yeah.
They're still in the loom, power loom business for weaving and so on. And their ideas about quality control much of it came from their experience prior to starting to build automobiles. And they were working on a loom, and they noticed the problem that when a thread broke, the loom didn't stop. And so it just kept going, right? And it used up lots of material, made a mess, but took a lot of trouble to fix it and to restore it. And so they were very proud when they developed a machine, a loom, that was able to detect a broken thread and stop it. And that became their basic notion for automation, or automation. That's why I asked the question.
Yeah. Should I make it quick?
Yeah, 2 minutes maybe.
Okay. So what benefits we have discovered is, of course, the increase in working capacity, more efficient utilizing of old materials. We can get accurate history from the road structures if we use some GPS kind of system where with help of which we can memorize the made procedures, so we can get information through there. And also the better quality and less costs and quality control. The automation gives us help when we plan the procedures. It is made easier and more accurate. If I say really quickly, so we can use the GPR measurements when we do the planning of rehabilitation, and we can localize the procedures through, for example, GPS, and the machine driver can himself watch the places where he has to do the procedures. The automation also makes possible to plan the thickness of the processed layer, and consumption of the binder can be planned more accurately. So what conclusion can we make? With the help of automation, the repetitive labor input routines can be decreased. The automation also makes possible to utilize plants more accurate. The biggest savings we have found is in the binder consumption, such as bitumen, and Pekka mentioned in his presentation about the bitumen costs, which are really big, at least in Finland right now. So the more accurate we can use the dosing, the more savings we can make. And our point of view is that the work is translated into a production process by nature, but it requires compatibility of planning systems and machine control systems, so the systems should be able to communicate with each other. And what challenges we have found in our organization is that it requires education of personnel constantly. And in general, it requires the right attitude. It was in the morning when in one presentation was described that old dog and learning new stuff. So the right attitude towards automation, fearless attitude. So you have to take risks sometimes, and I think in our organization we have the attitude. Also, it requires a partnership between the client, meaning, for example, the road administration, what they want, technology companies, researchers, and the constructors, that we can build something that is working. And that's why I think we are here today and tomorrow, so we can find out some things that needs to be done better. So at this point I want to thank you, and if you have any questions, please ask. Easy questions.
Any questions from the group? Okay. Oh.
Okay.
I'm just curious if they are planning on doing more on it. I noticed that you've done the one machine. Are you going to be looking at other aspects of your construction to try and automate that?
Actually, we have 4 machines, what we have made, but this particular machine is the one with most automation. So we have built 4 machines. And I think that maybe in the future we make some more if there comes the need, and maybe if you need some, that's not impossible.
Thank you, Anna.